Okay, hello everyone in a new video. So on this one we are going to solve an exercise related to electricity in the chapters of DC voltage and resistors. This exercise was a previous one in the brevet exams in 2013, second session, second exercise. The title of this exercise is Normal Functioning of a lamp. The circuit of figure 1 consists of a generator G delivering across its terminals a constant voltage AC is equal to 12 volts. Then the trick in solving such type of exercise is to write the given voltage on the electric circuit itself as well as the electric current. Then the voltage UAC of the generator G is given by 12 volts. A resistor D of resistance R, then this is the electric component D. A lamp L carries the inscription is 9 volt and 30 milliamps. Notice that I didn't label these inscriptions on the lamp L because yet we don't know if the lamp L is functioning normally. A closed switch K, an oscilloscope connected across the terminals of D. So these are the terminals of the oscilloscope. The aim of this exercise is to determine the value of R of D in order to let the lamp function normally. Yet we don't know if the lamp L is functioning normally. Then part 1 of this exercise. Role of D. Now in number 1 they are telling me what do the inscriptions 9 volt and 30 milliamps of L represent. Then 9 volt. Now because volts is the unit of voltage, so this is given by the rated voltage of which electric component of the lamp L. Under which it functions normally. And what about 30 milliamps? We know that milliamps is a unit of electric current, so it's the rated current of which electric component of the lamp L. Under which it functions normally. Now in number 2 they are telling me if L is connected directly across the terminals of G, it burns out to justify. So notice that the terminals of G or the generator G has an applied voltage which is equal to 12 volts, whereas the lamp L has a rated voltage which is equal to 9 volt. Because the applied voltage is greater than the rated voltage, then we have a probability of the lamp L to function strongly or burn out. Here they are telling me it burns out. Then let's say since the applied voltage is greater than the rated voltage, of the lamp L, and this is because 12 volts is greater than 9 volts, then the lamp L burns out. Now in number 3 they are telling me deduce the role of D in this circuit. D is the resistor R. We know that any resistor has two roles, either to transform electric energy into thermal energy, which is known as heat, or to protect other electric components by limiting the flow of electric currents. Here, because they are telling me deduce, and deduce means that we need to use the part just previously before. In part 2 we have talked about why L has the probability to burn out. Therefore the role of the resistor D is to protect the lamp L by limiting the flow of electric current. Then the role of D is to protect the lamp L by limiting the flow of electric current. Then this is it for part 1 of this exercise. Now in part 2, they are telling me exploitation of the waveform. Figure 2, they mentioned figure 2, then now we can use it. Shows the waveform displayed by the oscilloscope given that the vertical sensitivity SV is equal to 1 volts per division. Also another trick is to write that the vertical sensitivity on the screen of the oscilloscope. So here let's write that SV is equal to 1 volts per division. Now part A, they are telling me, does the oscilloscope measures UAB or UBA? Justify. And this can be justified by referring to the connections of the oscilloscope, knowing that always the oscilloscope measures from the phase terminal to the mass terminal. Notice that here the phase terminal is connected to the terminal A or the point A, and the mass terminal is connected to the point B. Therefore, the oscilloscope measures the voltage UAB across the electric component R. Now, since the phase terminal is connected to A, and the mass terminal then the oscilloscope measures UAB. Now in part B, they are telling me calculate the value of UAB, and this can be calculated by referring to the waveform or to figure 2. So let me make some space here. Now we are in part B. Now the voltage displaced or the voltage measured by the oscilloscope can be calculated using the following formula. U is equal to SV multiplied by Y, knowing that the oscilloscope is measuring UAB. Now the value of SV is given by 1, and Y, notice that here the luminous line is displaced upward, so Y is positive, and it's displaced by 1, 2, 3 divisions. Then this will give us 3. Since SV is in the SI and the value of Y is in the SI, so the value of UAB will in the SI, which is volts. Then UAB is equal to 3 volts. And I repeat that the trick in solving such type of exercises to write the voltage on the electric circuit. Then here we know that the voltage across the resistor R is given by 3 volts. Now in part C, they are telling me deduce the value of the voltage UBC and name the use law. Then deduce means that we need to use the part just previously before. In part B, we have determined the voltage across a branch. Then we can calculate the voltage UBC using the law of addition of voltages. And always in physics, whenever we use a law, we need to mention the law that we are using. Then apply the law of addition of voltages. And how do we apply this law? Always on the left we write the voltage of the battery or the generator, which is given by, in this case, UAC is equal to 12 volts. So usually the points A and C are located near the generator. So, but in this case they are located here. Then UAC, and on the right, on the other side, we write the voltages across different electric components, starting from A and ending with C, then from A to the point B, and from B to the point C, and we are interested in calculating the value of UBC. Now, okay, the value of UAC is given by 12, the value of UAB is given by 3, plus UBC, we keep it as an unknown. Then the type of this equation is a linear equation in one unknown, which is UBC. Then UBC is equal to 12 minus 3, which is equal to 9. Now, since 3 is in volts and 12 is in volts, so the value of UBC will be in volts. UBC is equal to 9 volts. Now, in number 2, they are telling me L functions normally, justify. Notice that now in this case, the applied voltage, because of the presence of the resistor, is given by 9 volts. And the lamp L has a rated voltage is given by 9 volts. Since the applied voltage is equal to the rated voltage, then the lamp L will function normally. Since the applied voltage is equal to the rated of the lamp L, and this is because 9 volts is equal to 9 volts. For this reason, then the lamp L will function normally. Now, because the lamp L carries two indications, 9 volt and 30 milliamps, so not only that the applied voltage now is 9 volt, but moreover the electric current traversing the lamp is given by 30 milliamps, because this is an indication of the lamp L. So this is the positive pole of the battery, this is the negative pole, then the electric current will be in this direction. So the electric current I traversing the lamp L is given by 30 milliamps. Now, part 3 of this exercise, determination of the value of R. Number 1, specify the value of the intensity I of the current traversing the circuit. Now, notice that all of these electric components are in series. The battery is in series with the resistor because they have one terminal common, the point A, and the lamp and the resistor are in series because they have one terminal common, the point B. Therefore, the three electric components are in series. And because the lamp is functioning normally, so the traverse current is given by 30 milliamps, then the value of the intensity I of the current is given by 30 milliamps. Now, since the lamp L is functioning normally, then the traverse current is equal to the rated current. Then in this case, I is equal to 30 milliamps. Knowing that milliamps is not the SI unit of electric current, in order to convert from milliamps to amps, we simply divide by 1000. Then 30 divided by 1000 will give us 0.03 amperes. Then the value of I is given by 0.03 amperes. And now finally, number 2, they are telling me deduce the value of R, and deduce means that we need to use the part just previously before, which is part 1. Now we know the value of the traverse current and we know the applied voltage. We can deduce the value of R. Okay, so here, sorry, the value of R is across, so the value of R is for the electric component D. So because the lamp L and the resistor are in series, so they are traversed by the same current, which is I is equal to 0.03 amperes. So now we know the value of the traverse current, which is 0.03 amperes, and we know the applied voltage across the resistor R. Then we can determine the value of R using Ohm's law. Then apply Ohm's law to D, which is the name of the resistor. And this law is given by that U is equal to R multiplied by I. Then U at the top, R and I at the bottom. We are interested in calculating the value of R, which is denoted by R. And the applied voltage across the resistor R is given by UAB, having a traverse current given by I. Then 3 divided by 0.03 will give us 100. Now since U is in the SI and I is in the SI, so the value of R will be in the SI, which is ohms. Then R is equal to 100 ohms. And by this we have finished solving this exercise. Hope it was beneficial for you guys out there watching it, and see you soon in another one.